Thank you, Mariana. By the way, Nikos is not writing tongue twisters. That was also ChatGPT. We had to do something. So, as you all may have already seen, I am a DevOps, and this will be a DevOps conference. As to what I'm doing here at your Dev conference, we just don't have as many DevOps conferences here, so we just jumped at the opportunity to spread the word. I have spread out a few DevOps engineers here, so to make it so that there's interest in this, actually. Who am I? I'm Nikos. I have been in the past 6 years a DevOps and a practice lead at Tarmac. And I am a huge geek, interested in every bit of practical technology aimed to improve your life. Or as my wife would say it, it's a pen, but also a clock kind of guy. And if you understood that, then you're old as me and I'm buying drinks later. So a bit of info on me, but if you want to find me, of course you can. So let's move on. So today I will be talking about when your application hits it big and you start receiving huge amounts of traffic. And as Gote said in the first presentation, like there's a point where serverless will just not work for you. You need to think big and also handle a lot of things. So I'm not going to talk about basics of setting up your infrastructure, security, etc. I hope you get that covered. I hope you're following Exonac's advice and Stefan's advice on how to do your test parallel work and all of that so that your application will work perfectly. I am going to talk about how your infrastructure needs to work perfectly and things related to AWS. Mostly because AWS has the biggest chunk of the cloud market, around 32% as of recently. Not to take anything away from the other providers, they do a pretty good job, although I'm not a big fan of Microsoft, so I'm biased here. If anyone's offended by that, I'm buying drinks later too. One of the big things here is going to be cloud cost, because as you grow and scale, there are some tricky things that happen, and that cloud bill will hit you at one point, and you need to be prepared for that. One thing I want to touch up on is collaboration and communication. I believe they are the key to success for any team, and in my opinion, a mediocre team that communicates well will do a lot better job than a team of superstars that don't talk to each other. So in short, talk to your colleagues. Sometimes they will listen. So some key AWS services I want to touch upon today, and I assume as you grow, your application has been containerized. If not, you need to do that. Some ways of managing containers that AWS will offer are EKS or Kubernetes and ECS. Now, conversation between which one to choose can be a lengthy one, so I'm not going to go into that, but I want to say that as you grow, you might want to think about keeping things simple. So to me, ECS has always been able to do a good job at that, because Kubernetes does bring a sort of complexity to everything. That being said, I'm not against it, so it's all good if you use it. Now, one thing that's really related to spot costs I'm going to talk about is spot instances and some ways to manage them. I'm going to talk about load balancing and what your options are there as you grow. And of course, the inevitable Route 53, which is the AWS DNS solution and how to handle your traffic. And of course, monitoring, we can't go without it. Now, let's start off with ECS. You might want to choose the ECS EC2 option, which will allow you to manage your instances as opposed to Fargate, where you don't get to manage them, simply because this will allow you to choose a large variety of spot instances, which will bring the cost down in the long term. I will talk about how you need to, I am talking about, of course, you need to spread your application into multiple AZs. I'm assuming for availability you also do that. But the aim here as you grow is to try and pick an AWS region that has as many AZs as possible to be able to have the larger availability of instances, giving you higher availability. And of course, there's an option with ECS called Replica, which is one of the native task schedulers that ECS has, and there's an option called dynamic host port mapping. This will allow you to run multiple containers of your application on a larger instance type, further increasing the amount of instance types you can use and increasing your availability in the process. And of course, one collaboration opportunity here would be application health checks, not strictly related to ECS, but your application altogether. Designing a quick and thorough health check will help you scale faster, will help you, aside from, of course, making sure your application has started safely, it will help you scale faster, which might be a thing when you grow and the traffic hits you. And now this is just one example, something that we did for a customer way back. This was an application that was handling around 2 million requests per minute while sitting in a private subnet behind a NAT gateway. Now those 2 million requests per minute, because of the data transfer going through the NAT gateway and the way AWS will charge you for services, have generated around $100,000 in monthly cloud costs for that particular customer. Simply by moving the workload and the instances to a public IP, by avoiding that, because public cloud traffic is free with AWS, we managed to avoid that and cut $100,000 of the monthly AWS cost. This is just one specific thing, but it shows you how you need to focus on some strange things that you don't think about when you don't have as much traffic. Now, I'm not going to talk about how to set up your Kubernetes cluster. I'm assuming if you use it, you already know how to do it. I'm just going to touch up on some things that are important for today's topic. Like, instead of using the Kubernetes standard autoscheduler, you can use something called Carpenter, which is meant to replace that and bring some neat features to the table. Like, it has the options to have you use your fleets with spot instances primarily, while you can also fall back to on-demand instances when spot instances are not available, and make sure you have high availability in the process. And a big feature that Carpenter also has is that it makes direct API calls to EC2. Compared to the standard autoscheduler that Kubernetes has, it will call out to an autoscaling group, which in turn will call out to EC2 and create an instance for you. By going directly to EC2's API, Carpenter will probably save you about 1 or 2 minutes in instance startup time, making sure you have quick startup time for your instances, and making sure that when the traffic hits you or you have big traffic spikes, you can handle that and scale up fast. Now, I'm assuming if you have Kubernetes, you already use either horizontal or vertical pod autoscaler. I just want to stress out how important it is to make sure that you tweak out that so that it runs fast, but also combine that. I'm assuming if you are a Kubernetes, you are running microservices, so you have multiple services communicating with each other, and something like pod affinity or anti-affinity will make sure that your microservices are grouped strategically so that you bring down latency in communication between them, but also bring down data transfer charges from them communicating with each other. Now, one of the big things as you scale in business, you scale in traffic, is maintaining your application scaling. Something I want to do is analyze traffic patterns. I will probably look at like the last 24 hours or 7 days and see if there's a pattern to that. There usually is, and I will use that to decide whether I want to go with target tracking or step scaling. Target tracking being where you set out a threshold, and the target scaling policy will do everything in its power to make sure that it stays within that threshold, versus step scaling, where when that threshold is hit, it will either subtract or add a certain amount of containers. Now, for me, usually target is the way to go, but based on your traffic patterns, step scaling can be known to do a better job at some points. Now, another collaboration opportunity here is to know your application, have your teams work together into creating custom application metrics, which can also be combined with your scaling policy, making sure that you are tracking the correct behaviors and scaling based on those. Scaling usually comes down to either CPU or memory in most cases, but sometimes there's specific behaviors that you want to track with your application, and this is where custom metrics come in handy, where you can track something and scale based on that to make sure that everything gets covered. And another thing that will definitely speed up scaling is knowing, again, I'm saying knowing your application, and I really mean that, like analyzing your application start and stop behaviors and how everything gets handled here, and making sure you devote work into tweaking that can help you by starting your application faster, can help you scale faster when that traffic hits. And of course, by doing that, you can adjust and tweak your scale in and out timeouts, and again, make sure that everything is running smoothly and quickly. Now, I could talk about load balancing for a couple of hours probably. Some colleagues of mine here can attest to that, as I have bored them to death a million times with it. But I will just stick to the key things relevant here. Now, AWS will give you an option to run an application load balancer, which runs on layer 7, and a network load balancer running on a layer 4, with a bit of magic to it, so not really layer 4. The NLB to me is the quickest one, reduces your latency, and it's also cheaper. But there are some cases when it just won't do because there's some complexity to the routing rules, and you just have to use ALB. But with that being said, there are situations where I would recommend running multiple NLBs to tackle certain specifics of your traffic, just in order to make sure you're running NLBs and you're cheaper and faster with that. Now, one thing that AWS will do here is they will charge you a lot of money as that traffic hits you by something called an LCU, which is a load balancer consumed unit. It actually tracks a couple of parameters, like data transferred, new active connections, and the amount of rules you have. And how it goes is whichever of those will generate the most LCUs is what you get charged for. But this can be a lot of money. Like, for example, on a specific customer of mine, which was handling, was running an ALB and handling 2 million requests per second, which is quite a lot. Not simply, but by switching from an ALB to an NLB, we were able to save them around $150,000 of the monthly bill. So one less headache. Now, analyzing your LCUs or what you get charged for is something pretty important that gives you the opportunity to tweak stuff. For example, let's say you get charged for data transfer. Now, with 2 million requests per second that I mentioned earlier, every byte makes a huge difference. So some things you can do here is have your teams, again, work together, collaborate, identify what that is, find ways to either compress the data being sent, or maybe identify unused headers, maybe cut some headers, cut them short. Again, every byte here will make a huge difference, and one less headache for you to think about when that bill comes. Now, there's also some third-party solutions that you can consider here, or either run them on AWS or take your picking, but they can also be combined with the existing ALB or NLB. So the solution I mentioned earlier, where we were able to switch the customer to an NLB, it took a lot of heavy lifting, but at the end we combined it with Envoy. Envoy is an open source edge proxy, which is very, very efficient, by far the best I've seen from everything I've tested. Combining that with the NLB actually allowed us to switch the customer from an ALB to an NLB, with Envoy adding the complexity needed to run through ALB, and NLB providing the speed and, of course, being cheap. Now, I mentioned spot instances a couple of times. For those unfamiliar, AWS has a few species of instances, mainly on demand, which you pay full price for the instance you buy, and then reserved, which you reserve a certain capacity for a certain amount of time. You either pay up front or not, but it's cheaper. And then Spot. Spot is actually AWS's idle capacity that they let you run until someone else needs it, and they can cut it short at any point. But they advertise it to be around 90% cheaper. It never is, but it is a lot cheaper. Now, because of the nature of Spot instances and the fact that they can get shut down at any point, you need a way to manage them as groups. With AWS, managing groups usually comes down to something called an autoscaling group or a split. Now, ASG's native autoscaling group, it works. It has some kinks, but I can definitely say it doesn't work in every situation. It will not let you fall back from spot instances to on-demand. And because spot instances operate on something called the spot market, where, as I said, they can get taken away at any point, You have to make sure that you have high availability, so finding a way to have your application run on spot primarily, and then have the option to fall back to reserved, on demand, or both when things get difficult, would be the best way to manage your instances. And ASG just doesn't do that yet. They have been working on it, but probably in a couple of years. And now something you can do here is leverage a third-party service like Spot.io. Spot.io will manage your fleets as groups very efficiently, very quickly. They will do a lot, and they will end up charging you 20% of what they save you. So a bit of a trade-off there, but definitely worth it. And of course, I mentioned it earlier, you have to find a way to utilize as many instance types and generations as possible. So for a one customer that we have ended up using, I think 140 different instance types and sizes, making sure that spot instances are also available for us at all times. And now, another collaboration opportunity. Because of the nature of spot instances, as I said, they can get taken away at any point, at which point AWS will send you a notification probably 2 minutes before the instance gets killed. So you have to work together and find a way to get everything drained, everything shut down without losing any data gracefully within those 2 minutes. This is a must with spot instances. Now, something not really related to spot instances, but they are available as spot instances, are Graviton instances. I honestly didn't know where to put them, so I figured why not here. These are ARM-based instances that are a bit cheaper, that they spend less power, so eco-friendly, go green. And they have been advertised to perform up to 40% better than the alternative instances. I've never seen it happen, to be honest. At most we've seen, and I'm looking at you, Spiro, at most we've seen like 10 to 15% improvement, still an improvement. However, running your application load on an ARM-based instance can be like very difficult. It takes some heavy lifting, so a thorough investigation is advised before you decide to do this. Now, one thing you need as you grow, is making sure that you analyze your traffic origins, because having your application run in one data center and receiving application from the whole world can increase latency somewhat. So analyze your traffic origins so that you can spread your application to multiple regions, and thus improving latency. You can do this by leveraging something called Route 53 traffic policies, which will let you use geolocation, geoproximity rules, and some weighted rules for seamless shifting between one or two endpoints. Now, I wouldn't be a DevOps if I don't talk about infrastructure as code, or my colleagues here will probably jump me right after, so this is a must. It doesn't directly impact your application performance. It does affect your infrastructure performance by letting you maintain your infrastructure state and stability, by letting you roll back quickly when you decided you made a mistake, which we all do. And of course, you can modularize it to quickly deploy to multiple environments and regions, and maintain them with ease. It's all I'll say here, but if you're not using infrastructure as code, my go-to is Terraform. There's a lot of other options out there. You should think about doing it. Now, last but not least, the almighty monitoring. This is, I'm assuming everyone is already monitoring their application, but as you grow, some things really get a bit more difficult. Like carefully choosing your observability tool and seeing if it can do things like, or maybe not do things like charge you per metric, because as you grow, the amount of metrics that you host really grows, like running 2,000 containers, all of them generating, I don't know, 1,000 metrics. It will get expensive. So what I would say here is, if you already have a solution that you're working on, don't shy away from thinking about changing it, because it might not work for you. As things grow, some of those solutions will crash and not be able to load stuff. For example, my go-to is Prometheus and Grafana. For that same customer with the heavy load, we have used Amazon Managed Grafana. It was just not able to handle the load. It would crash all the time, so we ended up moving them to Grafana Cloud, which works wonders. Now, again, you are doing this, you are monitoring your application. If you're not, it's a big mistake, but you have to, as you grow, identify some key metrics for you, but also think about things like whether you want to monitor your average from that application or do you want to see per host metrics. With 5 to 10 containers, if a couple of them fail, the average will jump right away, you will get alerted right away. With 2,000 containers, if you have a small problem, nothing's going to happen to the average. So you have to think about either looking at per host metrics or do things like a P99, P95, which is the 99th and 95th percentile, while also looking at P50, which is your average, to be able to identify some issues. And again, I've mentioned it earlier, creating custom metrics can also help you do that. I'm going quick because there's not a lot of time, because I want to get to this. This is really important. As you grow, all AWS services have some limits. There's soft limits, which when you hit them, your service just cannot grow anymore, and you have to request for an increase by AWS. Depending on the support plan you are on, it can take from 15 minutes up to 24 hours. 24 hours of unavailability is a no-go for all of us. But there's also hard limits that when you hit, you have to think about re-architecturing your infrastructure, which can be cumbersome. So a simple trusted advisor and an SNS solution that will alert you when you hit like 70 or 90% of a limit well in advance can help you avoid this. I have a lot of war stories about things happening to me. It has happened more than I would like to admit. So if you don't want your name to pop up in a couple of board meetings, you got to do this. Now, there are things that I can't talk about because we don't have the time, like RDS, Elasticache, serverless to handle some specific situations. You can find me later and we can talk about all of this if any of this piqued your interest. Thank you.
Thank you, Nikos, for this comprehensive, brief but yet comprehensive presentation. Let's move to the questions part. I already see a hand up there in the middle.
Okay, great presentation. Since I'm quite noob in the DevOps field, I wanted to ask you about, is it a necessity or a must to use Kubernetes and containerized apps in order to leverage all of the pros from Terraform?
No, absolutely not. I mean, like I said earlier, nothing against Kubernetes, but you have to think about whether the complexity it brings outweighs not the complexity, sorry, the benefits it brings outweighs the complexity of it. Because at some cases, like I said, especially with huge growth, it's necessary to keep things simple.
Thank you.
Thank you for your question. There is a question over here in the front.
Yeah. Nikos, great presentation. You mentioned a lot of like general topics here, but I would be interested in finding out like specific numbers, if you can share them. You mentioned EC2, ECS. So like how many EC2 nodes and ECS containers and services does your team manage? And also I would like to hear a bit more about how exactly do you handle the multi-region, which I presume you already have, like how many regions and how do you handle that traffic?
Yeah, thank you. So I mentioned most of that, but I have to stress out like finding a way to use as many instance types as possible is a must. At one point, I think we have been using for about 130 to 140 different instance types, which, as I said, are bigger. So there are up to 32x large instances there, which can handle a lot of containers. But we have been known to grow up to 2,000 containers spread out throughout 4 regions. We manage that by Terraform, as I mentioned, with Terraform modules. It will make it very easy to use the same structure for all of your regions just by tweaking out a few environment variables like a region and environment. You make sure that you have everything set up the same across all of your regions.
Thank you. Hopefully that satisfies your answer. We have one more question here in the middle.
Hi, Nikos. Hi. It's okay. I have a question about traffic patterns. You mentioned traffic partners. Can you explain why are traffic partners, and can you mention a few?
Well, if you're referring to where I was talking about growth, so it's very important to see like throughout 24 hours, I'm assuming if you're receiving traffic for multiple areas, traffic can grow as people wake up or go down as people go to sleep, depending on the nature of your application. It's a bit different. But aside from that, just knowing when you grow and go down in traffic, it's also important to know how your application is being used, or specifically whether that traffic growth is steady throughout the day or whether you have spikes. If you have spikes, you need to be ready for those. One thing I didn't mention is if you have an expected spike, what you can do is schedule something like Gotz's lambdas, and make sure that you scale up with an automated configuration before that traffic spikes hits you.
All right, that will be all for the moment. Thank you once again, Nikos.